Hi everyone, welcome to the second Swift tutorial. Today we're going to be going over for loops, if statements, and switch statements, as well as a couple other little things about print statements that I didn't quite cover in the first video. So, where do we start? For loops, right. In the words of an old friend named Isaac, what is a for loop? Well, I'm glad you asked. So, in principle, if I wanted to type the numbers 1 through 10, each on a new line, in normal programming, I would have to go print 1, and then print 2, and then print 3, and then print 4, and then print 5, and this is kind of pointless. So we can actually have the code do this for us. So let's say I want to print the numbers 0 through 9, inclusive, and well, I can do a whole video on why it starts at 0 at some other point, but for now, let's just write the Swift code. So we do for I in 0 ... less than 9, and then open brace. And in here, like, we just want to print out I. So what's this doing? Well, basically for I, so I is what we call our like incrementer. It's like the variable that is going to be modified every iteration of the loop, every time the loop runs through the code in the body. The body of the loop is everything between the braces. In separates what our variable is from our loop process or range. So this is actually shorthand for creating a range object, but we don't need to worry about that for now. What we do need to worry about what the heck this actually is. So what this is saying is I will start at 0 and it will keep going until it is 1 less than 9. So in actuality, this will print the numbers 0 through 8, which is not really what we want. So in order to go inclusive, as I specified here, we need to use the inclusive range operator by putting 3 dots like that. And if we actually hit run or press Command R, it will run our code. And as you can see down here, I'm going to make the panel taller and hide the left pane. And as you can see, we printed 0 through 9. Perfect. So another quick thing is that Swift did 2 things here from our last video. The first thing is that it automatically interpreted what the type of I was. So if we were writing in Java, or C, you'd probably write for int I equals 0, I is less than, I is less than or equal to 10 or 9, I plus plus. So Swift just kind of figures these things out. So that's kind of the basics there. Next, let's go over, one more thing about print. So let's say I wanted to actually print all of these on the same line. In Swift, the way you do it is you add another argument to this print function. We'll go over functions in the next video, but just for now, you can type comma space terminator colon and then like a space like that. And if we run, you'll see that now it prints everything with a space between them. All right. So let's move on to the second topic, which are if statements. This reminds me of a quick little tip about comments. If you do the comment 2 slashes and then mark in all caps followed by a colon, it will actually bold. So if I do like for loops, it'll actually bold this to make it a little easier to find. So I'm going to do one for loops, and then I'll do one for if statements. So if statements are the basics of logic. So normally you use these to check Boolean values, and Booleans are anything that are true and false. In fact, they can only be true and false. So let's talk about if statements in the context of traffic. So let's say we have some sort of variable that tells us if the traffic light is red. So I will declare a let constant. So let traffic is red, and that will be equal to false. Now, you may actually be confused. This is not really correct. Traffic lights are meant to change, so as from the first video, we should not make this a let constant, but instead a variable that is mutable. And this is a Boolean variable. Boolean variables are variables that are either true or false and are essential to working with if statements. So let's say we want to check if the traffic is red. Well, it's just as easy as writing if traffic is red with an open brace, and then let's say we print, uh-oh, don't go, something like that. And and then else, otherwise, we print go, something like that. Now, this works just fine. If we print and run this program, we can see that since this is false, if traffic is red will not execute, it will go to else, and it will just print go. I'm going to insert a blank print statement up here, just so we have a little bit more room in our console. So this just prints like a new line for us. There we go. So, and of course, I can change this to true and rerun our code. And it will say, uh-oh, don't go. And that sounds like a cool band name, actually. Anyways, so what's next? Well, let's say we see we actually get more information from the traffic sensor, and we can actually tell if the traffic light is yellow. And we can actually tell if the traffic light is green. Now, this seems like a bit of an odd scenario because you would never have more than one of these conditions true at one time. However, electronics are very finicky, so it might be possible. So let's try to actually build a traffic light. So what are the conditions? So if it's red, don't go. If it's yellow or green, you can go, right? And those are really our two conditions because we only care about when you can go and when you cannot go. So I can literally just translate this to code. So if traffic light is red, go. Otherwise, else, if traffic is yellow, oh, how do we type or? In Python, you can type or, but since Swift is more of a mature programming language, you type two types. Now, you have to press Shift and then press the backslash key, which should be right above your Enter key if you're on an American keyboard, or just to the right of the bracket. And this will basically evaluate either condition. So traffic is yellow or traffic is green. And I'll print, in this case, we will print, oh, sorry, I messed this up. So this is don't go. And then this is go. So what this says is if traffic is red, it's going to print don't go. Otherwise, if traffic is yellow or the traffic is green, it prints go. And if we build and run, since all of these are true, it's going to actually trigger the most important one first. So we have actually two important takeaways here, aside from the syntax, of course. The first is that we have to name variables as descriptively as possible. If I just name this red, yellow, and green, this might make sense, if you're working in this application for quite some time and you kind of know what these variables are and you know the problem that you're in. However, when you're working in software or just working with other people in general, people need to be able to understand what your code is. And of course, you need to be able to understand it 3 weeks, 3 months after the part that you've written it. You'd be surprised. It's quite easy to forget where you are. So I personally like to make my variables as descriptive as possible. The second thing to take away here is the order that I put these commands. If I put this command first, it would actually trigger this one first, because in this weird case, these two are both true. So you kind of have to think about, when you're programming logic in this way, you have to think about what is the most important thing, and you have to put that first. I've had a lot of bugs when that kind of thing happened, and no one really explained why. Finally, let's talk about switch statements. So I'm going to do another mark, switch. So switch statements are useful when you need to make a lot of comparisons. So let's say, for example, I have someone's age. So let's do let age equals 5. I will be 5 for the moment. And I want to compare, let's say if they're like 0 to 10, they get a huge birthday party. And then as they go older in groups of 10, they have slightly smaller birthday parties until the time when they're 100, when they have a very small birthday party. So let's do that. So if age, oh yeah, we get to learn about the comparison operator too. Wow, I really did that. Yeah. So if age is equal to 5, oh, wait, how do we do this? We want to check if age is equal to 0. In this case, print small birthday. And then otherwise, if age is equal to 1. And also, just to introduce this again, important point, if you are a new programmer, this is the equals sign. And if you put 2 of them, that's the comparison. Many a bug have been discovered by only typing 1 here. Don't do that. Make sure you have double equals when you're doing if. All right, so if age is equal to 1, actually no, I already messed this up. This will be a large birthday, and this will be a large birthday. And if age is equal to 2, this will be a large birthday. You can see how this will get tedious if I have to type this 100 times. Fortunately, we can use what we learned earlier in the for loop example. Wow, it's like I planned the lessons in advance. And we can use this range operator again too. But in order to do that, we're going to also use the switch statement. Switch statements are just a shortened form of doing if-else, and they're very useful. So in this case, I want to switch on the age because that's what we care about. And we want the case where the variable age is between 0 and 10, or let's say 9 inclusive. So when you're when you're inclusively from 0 to 9, in this case, we'll print big birthday. In the case where you're 10 to 19, print big birthday. And in the case when you're 20, 29, okay birthday, and so on and so forth. Now, switch has one important condition, and Xcode is already yelling at me, in that switch must be exhaustive. Since we're kind of defining the cases as it is, Swift also needs to know what to do when anything else is true. So what if my age is like 50 million? Well, I didn't define what it is here, and I'm not going to write 50 million lines. So we have a special keyword called default, and this case, this kind of default case occurs whenever something that we didn't specify happens. In this case, I'll just print meh, no birthday. So what happens when we run this? Well, let's set age to something like 23. We expect it to switch age, and we expect the case when the age is between 20 and 29, because 23 is between 20 and 29, and it should print okay birthday. So if I run, as you can see, it printed okay birthday. Another tip is I would recommend looking through and trying to run through your logic before you hit compile. It's going to be painful and it's going to be slow, but the more you do it, you kind of trick your brain into doing it for you, and you'll be able to think a lot faster than you might expect. And of course, if I try to change age to like 23, however many zeros are after that, it'll print meh, no birthday. One other quick thing to note about switch is that in other languages like C and Java, you normally have to type break after your statement. Oh, I should also note that you can make these multi-line. So as long as you indent them, actually not really as long as you indent them technically, but just for now, as long as you indent them like this, you can put other lines down here. So I can print like, and wow, you're young, something like that. So in other languages, you have to type break at the end of each of your cases. However, in Swift, you don't need to do this. Swift also has quite a few number of these statements, and these are called control flow statements. And these are things like break, continue, fall through, return, I can't type, and throw. We'll see these as they come along. I just kind of wanted to throw them in here. Can't get out of a pun in this video. I just wanted to throw them in here just so we can see what these are before we continue with our tutorials. All right, well, that is the second episode, and it is hopefully under 10 minutes. I will be posting the code on GitHub below, and should be in a link in the description. Thanks for watching, and let me know if you have any suggestions. In the next video, we'll be talking about, as I open up the page, we'll have a special episode where we kind of talk about Xcode and go more into this weird application that we're using for programming. I'm a nomad.